Hello everyone. Welcome to MRU E-Learning, powered by Malla Reddy University. Myself, Dr. Supriya, working as Associate Professor in the Department of Data Science, School of Engineering, Malla Reddy University. In today's session, my presentation is on the topic Page Replacement Algorithms. The overview of my contents are paging, paging hardware, paging model of logical and physical memory, and page replacement algorithms. So first, I would like to tell what is paging. So paging is a memory management scheme that permits the physical address space of a process to be non-contiguous. So paging is an example of non-contiguous memory allocation. So what is this non-contiguous memory allocation? So here, if we take a process which is of 5 MB, each and every process, wherever there is a vacant space, it will be allocated with that free or vacant space. So here, if we take 1 MB of data is allocated here, 3 MB of data is allocated here, and another 1 MB of data is allocated here. Rest of the space is occupied already. So here, 3 MB of data, that is, say the process name is P1. So process P1 is allocated in 1 MB of data. Process P1 is allocated in 3 MB of data, and process P1 is allocated in 1 MB of data, and remaining space is already allocated space. So here coming to the page. So every process is divided into number of partitions. We call them as the page. The size of the page must be same. So here in the logical memory, we have divided into equal partitions, which is called as pages. So we have page 0, page 1, page 2, and page 3. Coming to the frames. So here the main memory or the physical memory is divided into equal partitions, which is called as a frame. So here in the physical memory, each and every page is stored in the frame. Whenever a CPU wants to give some instructions, the CPU will send the instructions in the form of pages, and then we get the output in the form of frames. So here we have a page table. So whenever we give the input as the page number, it produces the output as the frame number. So if we take the page number and the frame number here, so in frame number 1, page number 0 is allocated. If we take the frame number 1, page 0 is allocated. If we take frame number 4, page 1 is allocated. If we take frame number 3, page 2 is allocated. If we take page number 7, page 3 is allocated. So in frame 7, page 3 is allocated. So next one is the paging hardware. So every address which is generated by the CPU, it is divided into 2 parts. So whenever a CPU wants to give the instructions, it gives the instructions to the logical address, and this logical address is divided into 2 parts. One is the page number and the other one is the page offset. So here page offset, we can also call it as the displacement. So whenever we are saying a displacement, whichever instructions we are giving, we can give the instructions in the form of lines, or allocation has been done in the form of pages. So coming to the page number and offset, the page number is used as an index into the page table. Here we can see into the page number, all the page numbers are given as the input. So the page table, it contains the base address of each and every page in the physical memory. So here we take the page number as the input and it produces the output as the frame number. So this frame number is sent to the physical address which is having the page number and the offset value of the frames. And further, we get the physical address which is sent into the physical memory. So whenever a CPU wants to execute the instructions are given in the form of pages and we get the output in the form of frames. So this is the paging hardware. So coming to the paging model of logical and physical memory. So here in the paging model, the page size is defined by the hardware. So the size of the page is a power of 2, which is a 512 bytes and 16 MB per page, depending on the architecture of the computer. And the selection of power of 2 as a page size, it makes the translation of logical address into a page number, and also we have a page offset. So if we take every paging model, it is divided into page number and page offset. So page number is given as P and offset is given as D. So here if we take an example, we consider we have the page size as 4 bytes and the physical memory is of 32 bytes. So if we take the logical memory, so in the logical memory, each frame is having 4 pages. So the page numbers are given as 0, 1, 2 and 3. And coming to the physical memory, each and every page is having 4, and here we are dividing the physical memory into 32 bytes. So 32 bytes means we have 8 pages. So whenever we want to access the data, we give the data in the logical memory or the process in the form of pages and we get the output as the frames. So here we are considering the page numbers as A, B, C and D, and here the page is here page number 0, this one is page number 1, page number 2 and page number 3. So here we have a page table. So in the page table we are taking the input as the page number and we get the output as the frame number. So here if we take in the physical memory, we have the frame numbers as 1, 2, 3, 4, 5, 6, 7 and 8. So here whenever we are taking the frame numbers, we allocate each and every frame with the page number. If we take frame number 5, it is allocated with frame number 0. Whichever elements are there in page number 0, that elements will be allocated in frame number 5. Similarly, frame number 6, whichever elements are there, those are allocated in page number 1. So in frame number 1, whichever elements are there in the pages, that will be allocated. So this is about the paging model and logical and physical memory. So coming to the page replacement. So whenever the CPU, it needs to execute a page, it will first check whether the page is present in the main memory of the computer or not. If the page is present, it will use the page. If the page is not present in the main memory, then we can say that a page fault has occurred. So here the page replacement, it deals with the selection of the page in the main memory, which has to be replaced when a new page must be brought in. So when a page fault occurs, the operating system will perform to check where the page fault has occurred. So first it will check the location of the desired page on the disk and it will find a free frame. So if there is free frame, it will use the frame. If there is no free frame, it will use any one of the page replacement algorithm to select a victim frame. So we write a victim frame to the disk and change the page and the frames also. So we restart the user process. So here if we see the diagram, so every time when a process wants to be executed or a set of instructions has to be executed, all the instructions are sent into the frame. So in the page table, we have a frame number and an offset value. So here we will check whether a particular page is available or not. If it is not available, we send the victim frame. It is a swapped out. And then we change to invalid. And then after changing to invalid, we have to swapping to the victim frame and then we reset the page table for the new page. Then only we can allocate the new page into the memory of the computer. So next we have a page replacement algorithms. So there are 4 page replacement algorithms. First one is first in, first out. Second is optimal page replacement. Third one is least recently used. And the fourth one is most recently used. So coming to the first one, that is a first in, first out. So this is a very simple page replacement algorithm. So in this algorithm, the operating system will keep track of all the pages in the memory in a queue. So that means the oldest page which is in front of the queue will be executed first. So here the page needs to be replaced in front of the queue in the selection of the removal. So we consider an example here with a page reference string. So this is a page reference string 1303563. The size of the frame here is 3 pages. So now we have to find out number of page faults by using a first in, first out. So here we can see the page reference and the size of each frame is 3. So here we can allocate only 3 pages. So initially all the slots are empty. So we allot page number 1 in the first location. Then we allocate page number 3 in the second location. Then we allocate page number 6 in the second location in the frame. So next, when we have to go to the next page, that is page number 3, it is already available. So it is already available means the page fault is 0 here. So we cannot replace that particular page in the frame. So next we come to the page number 5. So the page number 5, it has to be replaced, but our frame is full here. So now we have to empty the frame and then allocate the page number 5. So how we can empty? We use the technique of first in, first out. That is, whichever has been allotted first, that particular page will be removed from the frame and we allot fry here. So one is allotted first in the particular frame. So we remove that particular page number 1 and we allot page number 5 in the place of page number 1. Next we come to the next page, that is 6, which have to be allotted in the frame. So next in the FIFO, which one is empty now, which has to be replaced is the second location in the frame has to be replaced. So in the place of 3, I replace 6. So here the oldest page slot available here is 3. So I replace 3 with 6. So here 1 page fault has occurred. So whenever we are replacing the page fault, 1 will occur. If we are not replacing, page fault 0 will be occurred. Finally, when we come to page number 3, so it is also available here. So we need not replace that particular page. So next one is optimal page replacement. So in this page replacement algorithm, pages are replaced which would not be used for the longest duration of time in the future. So here also we consider the page references and the size of the page frame. So the page reference we have 7, 0, 1, 2, 0, 3, 0, 4, 2, 3, 0, 3, 2 and 3. And here the size of each frame is 4. That means 4 pages can be allocated in the frame. So coming to the first page, that is page number 7. Initially, as all the slots are empty, we can allocate page number 7 in the first frame. Next, page number 0 can be allocated in the second frame. Page number 1 can be allocated in the third frame. Page number 2 can be allocated in the fourth frame. So now coming to page number 0. So this page number 0, it is already available in the page frame. So the page fault here is 0. We need not replace this particular page number 0. So coming to the next page, that is page 3. So this page 3, we are using an optimal page replacement algorithm. So which is not used for the longest duration of time. So page number 3 is not used for the longest period of time. So instead of page number 7, we are allocating page number 3 here. So next, page number 0. So in page number 0, which is not used for the longest period of time, here already page 0 is there in the page frame, so we need not allocate any particular page here. So coming to page number 4. So in the page number 4, which is the longest period of time, which frame has not been used? So frame number 1 is not used here. So we have allocated 4 here, page number 4 in frame number 3. So next coming to 2. So page number 2. So page number 2 is already available in the frame. So there is 0 page fault. We need not allocate that particular page in the frame. So next coming to page number 3. So in page number 3, it is already available, so we need not allocate. Next, page number 0. It is already available in the frame, so we need not allocate. Page number 3 is also available, so we need not allocate. So page number 2 is also available, we need not allocate in the frame. Page number 3 is also available, we need not allocate in the frame. So next one is a least recently used algorithm. In this algorithm, the page that was least recently used will be removed to make space for the new page. So here we are using the concept of timestamps to keep track of the usage of the pages, and when a page is accessed, the timestamp is updated to the current time, and when a page needs to be replaced, the page with the oldest timestamp will be used to replace that particular page. So here we take an example, we take the reference string, and each and every frame is of size 4. So here in the page reference, as the page frame size is 4, we allocate the first page in the frame, next second page 0 in the frame, third page 1 in the frame, fourth page that is 2 in the frame. Next we allocate 0. But if we want to allocate 0 in the frame, it is already available in the frame. So the page fault here is 0. We are not allocating. So coming to the next one, that is page 3, which has to be allocated in the frame. So here in the least recently used, which one is the least recently used, which is not used? That is 7. So page 7, in the page of page 7, we are replacing page 3. So coming to the next page, that is page 0. It is already available in that particular frame. So the page fault here is 0. So there is no need to replace. So next coming to page 4. So page 4, we have to replace with the page which has to be used leastly. That is page number 1. So we are replacing 4 with page number 1. So coming to the next page, that is 2. So here 2 is already available in the frame. So here the page fault is 0. No need to replace. It is a hit. So next coming to the next one, that is 3. So 3 is also available in the frame. So no need to replace. The page fault is 0. Next one is 0. 0 is also available in the frame. So no need to replace. It is also page fault 0. Next 3 is also available in the frame. So no need to replace. The page fault here is 0. Next 2, it is also available in the frame. So no need to replace it. The page fault is 0. Similarly 3, it is available in the frame. So we need not replace. The page fault is 0. So coming to the last page replacement algorithm, it is the most recently used. So this most recently used algorithm, it follows the Belady's anomaly which can occur in the algorithm. So when we take a number of page faults, they are increasing, means the number of frames also are increasing. So this is called as Belady's anomaly. So here we consider the example which a page reference string. So this is a page reference string we are considering, and the page frame size is 4 frames. So here we are using the most recently used. That means which page has been used most recently in the frame, we will be using that particular page for replacing the other pages. So coming to the first reference string, so the page is 7. So first in the particular frame we send the page number 7. So next page number 0. So in page number 0 we allocate in the second frame. Next page number 1 is allocated in the third frame. Next page number 2 it is allocated in the fourth frame. Now the frame is full. Now we have to allocate page number 0. But page number 0 is already available in frame number 1. So what we do is, here the page fault is 0. So no need to replace the particular page. So now the next page is page number 3. So page number 3, which is the most recently used location, is we have used location frame number 2. So in that particular frame, instead of 0, we are replacing the page 3. So next one is page 0. So page 0, it is not available in the frame. So what is the most recently used page here? 3 is the most recently used page. So in the place of 3, we are replacing 0 here. So the next page is 4. So if we take the page 4, so this 4 is not available in the frame. So we need to replace. So where we have to replace is in the most recently used frame. So the most recently used frame here is 0. So in the place of 0, we allot the page 4. So next we come to the page 2. So page 2 is already available in the page frame. So we need not replace. So here the page fault is 0. So now coming to the next one, that is page 3. So if we take page 3, it is not available in the frame. So which one is the most recently used here? So the most recently used here is 2. So we replace in the place of 2 the page number 3. So coming to the next page, that is page number 0. So it is not available in the frame. So we replace it in the most recently used, that is instead of page number 3, we are replacing with page number 0. So coming to the next page, that is page number 3. So here in the frame, there is no page number 3. So we need to see where the most recently used page is there. It is 0. So we have replaced in the place of 0, 3. Page number 3. So next, page number 2. So page number 2 is not available in the frame. So what is the most recently used page? That is page 3. So we replace page 2 in the place of page 3. So next, last page is page number 3. So here page number 3 is not available in the frame. So here page fault is 1. So then what we have to do is we have to replace in the place where it is most recently used. So 2 is the most recently used. So we replace in the place of 2 the page 3. So here the total page faults, here we calculate the page faults as the total number of pages which has been replaced. So here the total number of pages are 12. So here if we consider the most recently used algorithm, the total page faults here is 12. So here we have calculated the total page faults as the 12. So in today's session, I have presented on the topics paging, paging hardware, paging model in logical and physical memory, and all the 4 page replacement algorithms, that is first in first out, optimal page replacement, least optimal page, least recently used, and most recently used algorithms. Thank you.